Okay, so in this lesson, members, we are going to see more of the parabola. So we are going to see the point of intersection of the tangents of a parabola. Now, we assume that if we have now a tangent at this point and a tangent at this point, if we extend these lines like this, it means they are going to reach a point and then they will intersect each other. Now we're asking, what is this point of intersection for those two tangents? So remember when we are getting the equation of a tangent at a point, we say what changes if the parameter is p, this is going to be the equation of a tangent. If the parameter is q, this is going to be the equation of the tangent. But anyway, let me go back and show you how. Now, because these tangents at this point and this point, of course, all of them are tangent to this one, and you say the gradient of the tangent and that of the curve are the same at that point. I differentiate this. Then at this point, I'll substitute the value of y at this p. Then at this point, I'll substitute the values of y at q. So now let us get the gradient of this curve. I'll say now 2y dy dx. If I differentiate, this side I get 4a. Divide through, so that this will be, now my dy dx will be 4a over 2y, which will be 2a over y. So now, we come now at p, what is going to be our gradient? Our gradient, you know that at p, the value of y at p is 2ap, which is going to give us now, which will be 1 over p. 1 over p, because this and this disappear. So now, I have the gradient of this tangent at this point. Now I have where it passes. So now, I'll say now, y minus y1 equal to m into x minus x1. This is how we get the equation of a line, because the tangent is a line. So now, I have y minus y1. This is the point, which is, then the gradient is 1 over p into x minus fp squared. You see, if you cross multiply, we have yp minus 2fp squared equaling x minus fp squared. Now when I take this side, is that I have y p equaling 2. Now I have x plus a p squared. So now I come at q. At q, we have a q squared, 2aq. But we say the gradient is the same. So now, from here, say our dy dx is 2a over y. So it's that here my value of y is going to be 2a over, this is x, this is y. 2aq, which will be 1 over q. And there to get the tangent, I'll say y minus y1 equal to m. Substituting in, I have my 1. Now x1 is the point where this tangent is passing. aq into x minus aq squared. And simplify, I'm going to get y cubed equal to x plus aq squared. The same idea. Now, I have this tangent now at p and this tangent at q. Now, for them to intersect, it means that you just solve them simultaneously. If this one is equation 1, this will be equation 2. So for them to intersect, it means that you just solve them simultaneously. So now, you see if I have there my yp equaling to x plus fp squared, then y cubed equaling to x plus aq squared. If I subtract these two, you see I'll be having now y is going to be common, so I have y into p minus q equaling to x minus x. It goes, I have now A is common, b squared minus q squared, and subtract this from this. Now the difference of the squares, I have my y, b minus q, equal to a into now, p now minus q, then p plus q. And it's that difference of the squares, this one goes, so that our y is a, then into p plus q. So this is the point, the value of y at the point of intersection. Now, if I have this as y, you can either use this or this to get the value of x. So I'm going to say from, I don't know if I clear now, I say from, okay. From this one, I know that. I'll have it right here. I have now from 1, I have yp equal to x plus ap squared. If I take this side, I have my x as yp minus ap squared. Substitute the value of y. Your y is going to be, is that your y is a into p plus q, then p, then minus ap squared. You can open the brackets. So when you open brackets, we have ap, and this we have ap squared, then plus this time this aq. So we have aq, this time this, and this, then minus ap squared. You see this goes away with this, so it's that your value of x is aq. So now meaning that orange, the point of intersection between two tangents of parabola are, the x is that, then the y is a p plus q. And that's all. So members, that's all we had for parabolas. I think this is the last lesson in parabolas. We are going to now ellipse, and also after ellipse we shall see hyperbolas. Don't forget to subscribe to the channel. Wait for more. I wish you the best.